So now we will pass to the second one. The second one is the next one is 3. Calculate the limit when x goes to 0 of x times 1 over x. So how we will do this? We have 1 over x is less. Voilà, عن طريق الحصر. 1 over x, which is less than or equal to 1 over x plus 1. And also we have that 1 over x minus 1 is less than the floor function of 1 over x, which is less than or equal to 1 over x. Okay, so we multiply all sides by x. So here by multiplying by x, we get what? So here we have x times 1 over x minus 1 less than or equal to x, the floor function of 1 over x, which is less than 1 x times 1 over x. So I will distribute x over 1 over x minus 1. I get 1 minus x is less than x times the floor function of 1 over x, which is less than 1. Now we will take, we will calculate the limit when x goes to 0. So now introducing the limit, we get limit when x goes to 0 of 1 minus x is less than the limit when x goes to 0 of x times 1 over x, which is less than or equal to the limit as x goes to 0 of 1. Now this is equal to what? And this is equal to what? This is equal to 1 less than the limit when x goes to 0 of x times 1 over x less than or equal to 1. Hence, finally, we deduce that the limit when x goes to 0 of x times 1 over x is equal simply to 1. Okay? So now we will, is there any questions before going to the fourth? So for the next one, so this is the third one. Now we will go to the next one. So now we will calculate the limit when x goes to 1 of 1 minus x tangent p over 2x. So we will we have the limit when x approaches 1 of 1 minus x times tangent of p over 2 x. Do you have any ideas? Here we will change, we will use the change of variables. Simply we put, instead of x, we put x minus 1. So here put in u is equal to x minus 1. We get x is equal to u plus 1. So when x approaches 1, we have u is approaches 0. So we will substitute the limit when u approaches 0 instead of x approaches 1. So here 1 minus x becomes minus u times the tangent of p over 2. Instead of x we have u plus 1. Now I will use another law. So here when this is equal to the limit when u goes to 0 of minus u times tangent of p over 2 u plus p over 2. We have and this is equal to using the trigonometric relations when u is going to 0. Here we have minus u times the tangent. This we have a formula for this. When we have a number a plus p over 2, it will becomes minus 1 over tangent of p over 2 u. Why we have this? This is simply because the tangent of any number x plus p over 2, this is a rule, is equal to minus 1 over tangent of x. Now we have another rule, which is the tangent of u is equivalent to u as u approaches 0. Why? Simply because the tangent of u is equal to sine u over cosine u. When u approaches 0, the sine is equivalent to u, and cosine 0 over cosine 0, which is equal to u over 1, which is equal to u. So hence all of this will be equivalent to the limit as u approaches 0 of minus u times minus 1 over this tangent now here is equivalent to p over 2u. So here is p over 2 times u. So now finally u goes with u, and this minus times minus 1 is equal to plus 1, and so this limit is eventually will be equal to minus plus 1 over p over 2, which is equal to 2 over p. Hence I will write the final answer. So the limit when x approaches 1 of 1 minus x times tangent of p over 2x is simply equals to 2 over p. Do you have any questions? Do you have any questions? S'il vous plaît, partagez le lien pour vos camarades dans votre groupe Facebook ou Messenger. Now we will continue to the if there is if someone has a question, simply activate your microphone and ask the question. I will continue to the next one. So we have 5. Now, so we have 5. Here we will write with the new color. Let's say this one. No. So we will use another color. So now we will go to the next one, which is the limit. The limit when x approaches a of what? The square root of x squared plus a minus the square root of a squared minus a all over x minus a. How we will do this? Firstly, we will multiply both the denominator and the denominator with we will multiply this with square root of x squared plus a plus the square root of a squared minus a all over same thing plus a plus the square root of a squared minus a. This will give us, this is equal to the limit when x goes to a of so we will have x squared plus a minus a squared minus a all over here we have x minus a times the square root of x squared plus a plus the square root of a squared plus a. So we will simplify this. So here we have plus a and sorry we have here plus 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 plus, so this become plus. So here we will simplify this by, so this a will go with this a. What remains is simply the limit when x goes to a of x squared minus a squared over all of that x minus a times the square root of x squared plus a plus the square root of a squared plus a. Now the nominator will be equal to, we have the limit as x approaches a of x minus a times x plus a all over x minus a times square root plus the square root a squared plus a, and here x squared plus a. Now we will simplify. This one will goes with this one. What remains simply is the following. The limit when x goes to a of x plus a over x squared plus a plus the square root of a squared plus a. Now as we will x will go to a, so this x is going to a and this one will go to a squared. So all of this will equal to a plus a over the square root of a squared plus a plus the square root of a squared plus a. And this is simply equals to 2a over 2 over the square root of a squared plus a. We will simplify 2 by 2. What remains is here is a over the square root of a squared plus a. And this completes the answer. Do you have any questions now? I will continue to the next one. So number 6, we will calculate the limit as of sine 2x times sine of x minus p over 4 when x goes to p over 4. And we have in the denominator sine x minus cosine x. So this is not easy, because when we do this and substitute, it will give me sine 2p over 4 times sine, here p over 4 minus p over 4, so over sine p over 4 minus cosine p over 4. So this is equal to square root of 2 over 2 minus square root of 2 over 2, which is equal to 0. And this one is sine 0, and this one is sine p over 2. So we have 0 over 0, which is an indeterminate form. So how to solve this? We will simply use the change of variables. We will put instead of x, we will use u is equal to x minus p over 4. And this actually becomes, so this will lead us that the limit when u is approaching 0 of sine, here we have 2 times, instead of x we have u plus p over 4 times sine u all over sine u plus p over 4 minus cos u plus p over 4. we will do some calculations here. So the first one, since we using this change of variable, when x approaches p over 4, u will approach the value 0. And also we have, since u is equal to x minus p over 4, this implies that x is equal to u plus p over 4. Now we have some calculations. The first one, which is sine of 2u plus p over 2 will becomes using the laws of trigonometric functions. This is simply sine 2u times cosine of p over 2 plus sine of p over 2 times cosine of 2u. And we know that that cosine p over 2 is simply equals to 0, and sine p over 2 is simply equals to 1. So all of this will equal to cosine 2u. Okay. The next one that we should simplify is this. Now we did this. Now we will go to sine u plus p over 4. So sine u plus p over 4, using the same rule, it will give me sine u times cosine p over 4 plus sine p over 4 times cosine u. Okay, and now we will simplify this. So cosine p over 2 is simply square root of 2 over 2, and sine p over 4 is simply the square root of 2 over 2. We factor out the square root of 2 over 2. What remains is sine u plus cosine u. So here we get cosine u plus cosine u. Now what we left off is the third one is this, cos u plus p over 4. So here we will calculate it. So cos of u plus p over 4, u plus p over 4, this is equal to cosine u times cosine p over 4 minus sine u plus sine p over 4. This one is equal to the square root of 2 over 2, and this one is equal to the square root of 2 over 2. So by factoring out the square root of 2 over 2, we get cosine u minus here, and then what remains is sine u. We will now substitute all these three formulas here. So I will take it. I will copy this, copy, so we paste. So this will becomes, this is equal to, the first one is equal to cosine 2u. So here we have the limit, always when u is going to 0, cosine 2u times sine u, all over, we have this one, the square root of 2 over 2 times cos u plus sine u, and we have minus square root of 2 over 2 times cos u minus sine u. So we will simplify this, so we get the limit when u goes to 0 of cosine of 2u times sine u over the square root of 2 over 2 times cos u plus sine u minus cosine u plus sine u. So this cosine will cancel with this cosine. Sine u plus sine u is 2u. So this is equal to cos 2u times sine u all over square root of 2 over 2 times 2 sine u. This 2 will cancel with this 2, and this sine will cancel with this sine. What we left off is cos 2u over square root of 2. So this is equal to cosine 2u over the square root of 2. And this is going to, when u is approaching the value of 0, to 1 over the square root of 2. Okay? So, is there any questions? Do you have any questions? So I will pass to the next one. So this is number 6. Now we will pass to number 7. 7, we will calculate the limit of limit of when x goes to 2 of arc tangent of x minus 2 over x squared minus 4. Actually this is equal to the limit when x goes to 2 of arc tangent of x minus 2 over x minus 2 times x plus 2. We know that arc tangent x is approaching x when x goes to 0. So we will put here instead, we will put u is equal to x minus 2. So u is going to 0 when x is going to 2. And you will have also that here x is equal to u plus 2. Therefore, therefore here we will here we have x is u that is going to 0. So tangent u, as u is going to 0. Hence, this limit becomes limit as u going to 0 of arc tangent of u over x minus 2 is simply u times here x plus 2 x plus 2 is simply u plus 4. So x plus 2, when we substitute instead of x, we put the value of u plus 2, it becomes u plus 4. So this is equivalent to u over u plus 4. Now u is going to 0. So this will u will cancel with u. What remains is 1 over u plus 4, which is going to 1 over 4 as u is approaches the value 0. Is that so? Finally, the limit when x approaches 2 of arc tangent x minus 2 over x minus 2 times x plus 2 is simply equals 1 over 4. Is this clear? Do you have any questions? So, David, Jasmine, Miss, Ahmed, Nolhuda, Sami. So now we will pass to the next one. Is 8. 8 says that you should compute the limit when x goes to plus infinity of 1 plus 1 over x all to the power x. This is very simple. We will calculate the logarithm of 1 plus 1 over x to the power x, which is equal to x times 1 plus 1 over x. And as x goes to plus infinity, this is going to 0, so this will approaches x times 1 over x when x goes to plus infinity, so this will cancel with this. What remains is 1. Hence, so the limit as x goes to plus infinity of 1 plus 1 over x to the power x is simply going to exponential 1. Okay? Now we will go to the number 9. So this is the most difficult among all of them. So number 9. we have limit as x approaches 1 of 1 plus ln x all to the power tangent p over 2 times x. So here we will consider the change of variable. Instead of x we will put u minus 1. So here putting u is equal to x minus 1. So as x goes to 1, we have u is going to 0. And also the first one which gives that x is equal to u plus 1. Okay? Now we have the limit. So this limit L is equal simply to the limit when u approaches 0 of the following value. 1 plus here ln of 1 plus u all to the power tangent of p over 2 times u plus 1, which is equal to p over 2 u plus p over 2. Now we have the tangent of p over 2u plus p over 2 is simply equal to minus 1 over tangent of p over 2u. We know this. This is a known formula. You could check it in Wikipedia or any textbook that talks about trigonometric functions. So using and we know also that tangent any value is approach x is x when x goes to 0, and we know that this value is going to 0, so this will be equivalent to minus 1 over p over 2 times u. And finally this is equal to minus 2 over p times u. This is a simple calculation. We multiply both the denominator and numerator by 2 and simplify. This will give us negative 2 over p times u. Now we will use another rule which says since 1 plus x is a continuous function and ln 1 plus u is equivalent to u when u goes to 0. This will give us that 1 plus ln 1 plus u is actually equivalent to when u approaches 0 is simply equivalent to 1 plus u. Okay, so we will substitute all of these in our formula, which is this one. Okay, so this formula now, which I will copy here, insert, draw, copy. So this will be equal to So this is equivalent using the equivalence relations when you approach 0 to the limit when u goes to 0 of so we have 1 plus u all to the power, here we have tangent, and this tangent is equivalent to, as we have seen, as we've seen here, minus 2 over p over u. And this is simply using the, we will use the introduce the logarithmic functions. So the ln of 1 plus u all to the power negative 2 over pu is equal to negative 2 over p times u times ln of 1 plus u. And this is equivalent to negative 2 over p times u times u. U will cancel with u, what remains is negative 2 over p. So this actually will go to exponential negative 2 over p when u is going to 0. And this is the answer for the last one. Now, do you have any questions? Do you have any questions? So that's it for today. Uh, if there is, we will. If there is, if you have any questions, you could ask them now before we leave this session to next time.
Excuse me, sir. Are you going to share the resources of this lesson?
Could you, Davies, please repeat the question?
Are you going to share this marking maybe on the Google Classroom so I can access it and review the answers? And the question is also because in the question we don't have the questions like answers.
I will put this on YouTube and then I will share the link in the classroom so you could go back and see the steps. And also, what is your remark? You said that you don't have the questions.
No, the question does not go, but I mean the solutions themselves.
Ah, yes, yes, yes. So you want to try yourself, then compare your answer with the mine.
Yeah, because I can think that I understand when I'm not I answer somewhere unless I have somebody.
Ah, yes, yes. So I will put this. I will put the video on YouTube, and also I will upload the PDF containing the handwriting solution. Okay. See you next time. Until next week, inshallah.